Hi class. So in this lecture I'm going to talk to you about ions. Previously it mentioned to you that atoms are neutral, and that's kind of important here as a starting point. Right? When we've looked at our atomic structure of carbon and things like that, they were all neutral. Protons and electrons are equal in number. And well, these ions are charged atoms. Right? So technically, sometimes atoms can become charged, but the thing is, if they become charged, we don't call them an atom anymore. We call them an ion. So the terminology changes a little bit. And anytime I would show you something and say, hey, this is a sodium atom, we have to assume then that it's neutral, not charged, as opposed to saying this is a sodium ion, which would then be telling you it's charged. All right, so we can have positive ions and we can have negative ions. Okay, I'm going to tell you here how we create those things. This is all about electrons. Okay, so positive ions, what happens is an atom loses electrons. All right, so check this out, because this sometimes people have an issue with kind of thinking, if I'm losing something, how's it becoming positive? But you're losing negatives, right? So if we have this set of charges that are neutral, that's neutral. 4 pluses, 4 minuses. Now all of a sudden I come in and I say, I'm going to get rid of that one negative charge. Well, then all of this together is now positively charged. So atoms lose electrons. It can be one or more, 1, 2, 3, 4, depends on the atom. All right, so when an atom loses electrons, it's becoming a positive ion. And then the negative ions are just the opposite. It's when the atom gains electrons. Right, so same kind of deal now. It's neutral, 4 pluses, 4 minuses. Now we come in and add another electron. That's got to be a negative charge. Okay, and then I want to show you one of these as a for real example. So sodium. Okay, on the periodic table, sodium looks like this. Okay, so how many protons? How many neutrons? And then how many electrons? Right, so 11 protons, 12 neutrons, 11 electrons. Okay, so we can draw our atomic structure then. Right, nucleus, 11 protons, 12 neutrons, and then we can put in our electron shells. Red dots are our electrons again. So we need 11. There's 2. Remember how many electrons the second shell can hold? It can hold a max of 8. We've used 2. We have 9 left. So this second shell is going to be full of electrons. So we put 8 of them in there, which means we need one more shell that has 1 electron in it. All right, so that is a sodium atom. Now, what happens to cause this to become a sodium ion? Okay, it's a positively charged ion, so look back up here. We're going to create a positively charged ion. It's going to lose at least 1 electron. So what happens here is this last electron that we see, this electron here, it's in a shell all by itself, which it doesn't like. And it sounds stupid to describe it that way, but like chemically it's true. It just doesn't like it. Electrons, or sorry, atoms like to have their outer shell full. So this shell can hold 8 and it's only got 1 electron. It just wants to get rid of that thing. Okay, so that's what happens to create this sodium ion. We're still going to have 11 protons, 12 neutrons. Okay, we're still going to have a first electron shell with 2 electrons. Second electron shell with 8 electrons. But now what we've done is we've taken that 1 electron and kicked it out. Right, so it's on its own. So this is now a sodium ion. And notice how I wrote sodium now. It's an Na with a plus, right? That matters, that we have that plus there. It shows us that we're talking about an ion. If you didn't have these pictures, I'm going to come back to this picture in just a sec, but if you didn't have those pictures and you just see in writing these two things, those are different, right? That's an atom, that's an ion. You can always tell that with ions. If you don't have both of them together, if you just had one, like this. So Ca, what element is that? Calcium. Okay. Now we see the Ca with 2 plus. Numbers just telling us how many electrons are involved. The fact that we have the plus there is telling you it's an ion. It can be minus, right? We can have negative ions, right? So the charge with the symbol is telling us that we now have an ion. And all of this is because we want the outer shell full. Okay, that's kind of the thing here that we want to keep in mind, is this atom wants the outer electron shell full. It's a rule in chemistry. There's a fancy name for it and all that. I don't care about the name, but we want to keep in mind that the outer shell likes to be full.